All right, ladies and gentlemen, there's a couple of things that we need to look at in our handout today. So our video notes are going to be example problems from the handout. Please make sure you have the handout, and please make sure you're looking at this page right here. So the first thing we need to talk about is we need to take a look at what it is we're looking at today, because this is craziness. Look at all these boxes and things and lines and there's our word polynomials. Look at all this nonsense that we got going on. So let's figure out what we're talking about. First off, we're talking about multiplying polynomials. So in the last class, we were adding and subtracting polynomials, which was pretty straightforward, and you guys did a pretty good job with that. But today we're going to multiply. And really, we're not even going to multiply. We're going to draw a little bit, and we're going to do some math. So the first thing we need to talk about is what does it mean to multiply polynomials? There's some keywords here. It says use the model given, which is this stuff right in here, to derive length, width, and area of a rectangle. All right, well, that should be good news because hopefully you know something about length, width, area, and rectangles. What is the relationship between length and width and area of a rectangle? That should be familiar from middle school. Length times width equals area. Length times width equals area. And okay, well, hold on here. That length times width, two things multiplied together equals something. Two things multiplied together equals something. All right, so we're going to have length times width equals area. So we're going to take this model and figure out how to multiply some stuff together to find the area. Well, in order to do that, we need to understand what this means. So let's look at what it says right here. Let this big square equal x squared. This big square equals x squared. All right. Let the skinny rectangle represent x. So every skinny rectangle represents x. And then here we have the little square. The little square represents 1. 1, 1, 1, 1, 1, 1. Pretty straightforward. So if we can see the shapes, we can know what they mean. Big square equals x squared. Skinny rectangle equals x. Little square equals 1. All right, so let's look at this. Length times width equals area. Well, the length is right here. The width is right here. And the area is all the space that it makes up. Let's take a look at what we got here. So first off, the length, and we're going to draw this in. See how this length right here, this length is the same as this length? Well, that has to be true because it's a square. So this length equals this length, and this length equals x. So I'm going to draw an x. And this length right here is the same as this length right here because it is a rectangle. And if this length equals 1, then this has to equal 1. And if this length equals 1, then this length also equals 1. And guess what? If this length equals 1, then what does this length equal? You guessed it, 1. So let's do the same thing with the width. This length is the same as this, and this length is x. So we're going to call this x. This length is 1. And this length is the same as this length, which makes it 1. So the length was x and 1 and 1 and 1. X and 3. X and 3. How can we write that with numbers and letters? X and 3. Okay, okay. Now, we got the same thing up here for the width. X, 1, 2. X and 2. X and 2. Hey, you like the math? The math is good, right? X plus 3 is the length. X plus 2 is the width. And if when we multiply these together, the length and the width, what do we get? We get this whole rectangle right here. In fact, let me find a highlighter. This, does that show up? Yeah, it shows up. This whole thing is the area that you get when you multiply it together. Well, let's see what that equals. It says x squared and x and x and x and x and x. Well, how many x's is that? That's 5 x's. So we got x squared and 5 x's and 1, 2, 3, 4, 5, 6. 6 ones. X squared and 5 x's and 6. X squared and 5 x's and 6. So we've used this model using algebra tiles, to multiply two binomials. You remember the definitions from last class? Remember these definitions? Binomials and trinomials. Binomials, trinomials. So what we're going to be doing today is we're going to be representing how to multiply length and width. To find the area, we're going to multiply two binomials to get a trinomial in order to find out what the area is. Length times width equals area. Length times width equals area. Now, something I just want to make sure that you understand is that anytime we're dealing with quadratics, anytime we're dealing with something with x squared in it, that equals area. We're talking about area. So that's how we do the first one. And the first couple of problems here on the first page, you are simply looking at what is given to you and then filling in the length and the width and the area the same way that I did here. Let's take a look at a couple of more problems. On the next page of your handout, let's do problem number 2. Now here's a little bit different because we're going to draw everything in. So I've got x and 1. Remember, this is the length times the width, the length times the width. So what we're doing now is we're going to take the x plus 1, x plus 1, and then here we've got x plus 3. So we're going to do x, 1, 2, 3. X, 1, 1, 1. Now to find the area, let's just close in the rectangle. Close in the rectangle, and then we're going to draw all of our horizontal lines and then all of our vertical lines. So the horizontal lines go between each one of the pieces, each one of the algebra tiles. There's the only horizontal line, because those are the only two algebra tiles, so we're going to put a horizontal line in between them. And now we're going to take the vertical lines, and we're going to put a vertical line in between each one of the algebra tiles. Vertical line, there's another one. Vertical line, there's another pair, so we're going to draw a line in between them. There we go. Now, that should look a whole lot like the first page. The big square equals x squared. The skinny rectangle represents x. The skinny rectangle represents x. What does this one represent? X. What does this represent? X. What does this represent? The little square represents 1. The little square represents 1. And the little square represents 1. So the length times the width, x plus 1 times x plus 3 equals, let's just see what we got. We've got x squared and 1, 2, 3, 4 and 4x, 1, 2, 3, and 3 ones. 1x squared, 4x plus 3. And we've just multiplied binomials. Length times width equals area. Length times width equals area. Now, you might be saying to me, Mr. Valdez, we haven't done one with negatives. How does that work? Well, I'm glad you asked. Let me show you. So here we've got two x's. This is the length and this is the width. So we're going to put the length down here, two x's. So I'm going to put in two skinny rectangles. Two x's, two x's. Now we're going to do the width over here. That's my x. And then here's the -2. So those are still 1. So that's still skinny rectangles. But here's what I want you to understand. To represent a negative, we're going to shade the tile. So if we have a shaded x, that equals -x. If we have a shaded 1, that equals -1. And if we have a shaded, oh, can't see it. If we have a shaded big square, that equals -x squared. So anytime we have shading, that means negative. So let's go ahead and do the same thing that we did earlier. And remember, we're multiplying. So we're going to fill this in, and I should move that over a little bit. So let's just, we'll make it work. Right here, we can draw our line, vertical line. Remember, this is the space that we're working with, this right here. 2, this right here. So this is the space we're working with. Because I'm not using this space because that's where this is written. So I'm only using this space right here. The length is 2x. The width is x plus 2. Or I'm sorry, x minus 2. So right here, let's draw we drew our horizontal line. Let's draw the vertical line. Let's draw the next vertical line. And let's talk about what we got. So we've got a big square, x times x, big square is x squared. Now look at this one. We've got another big square, x and x is another big square, that's x squared. And then let's talk about this one right here. We've got x, this is the x, and here's the 1. But this is a positive x, and this is a positive. What's a positive and a negative? Positive times negative equals a negative. So this is negative x. This is really shaded in. Positive times negative is negative. This is a negative x. Positive and a negative make a negative x. A positive and a negative make a negative x. So here we've filled everything in. We've labeled it correctly, x squared, and our negative x's. So what's our answer? 2x times x minus 2, length times width, equals, let's count everything out, 2x squared, but what do we have here? What is this? 1, 2, 3, 4. That's 4 x's, but they're all negative, minus 4 x's. So when we've got negatives, when we've got negative numbers, we're going to use shaded algebra tiles to represent the negatives. And then we're going to also we're going to make sure that when we combine like terms that we bring the minus sign, the subtraction symbol, the negative into the answer as well. 2x squared minus 4x is exactly what we've got here. Let's do one more example. Let me find the one I was going to do. I know I had another one. Let's do this one. Let's do this one. All right, so length times width, it's written here, length times width. So let's go ahead and put those in. So we've got our x, 1, 2, 3, 4, and look, they're all negative, so we're going to shade those in. And then we've got the width, so we're just go ahead and draw that x in. And then we've got 1, 2, 3, 4. So far, so good? All right. So now the next step is to draw in the length and the width, the rectangle. Now I've got my space that we're finding, length times width equals area. So what we're going to do now is we're going to put in all of the horizontal lines. So there's 2 algebra tiles, so we're going to separate them with a line. 2 algebra tiles, we're going to separate them with a line. 2 algebra tiles, separate them with a line. 2 algebra tiles, separate them with a line. Now, we're going to do the same thing with the vertical lines. We're going to drop vertical lines down in between the algebra tiles. 1, and then there's another one right there, another one right there, and another one right there. Now, as long as you draw your shapes the right size or the same size, then you can actually see all the different pieces. So this piece right here is a large square, so that's x squared. Skinny rectangle, positive and a positive make a positive, so that's a positive x, positive x, positive x, positive x. Now, down here we've got a positive x, and we've got negative ones. Positive and a negative multiply to get you a negative. So this is a negative x, negative x, negative x, negative x, because these are all skinny rectangles. Positive and a negative make a negative, so we're going to shade all of these in. Now, right here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so these are all ones. The little squares are all ones, but a positive and a negative make a negative. So this is a shaded. Positive and negative make negative, negative, negative. All of these, positive and negative, make a negative. So all of these ones are going to be negative. Now, when I write my answer out, I want us to do it, I want you to notice something. So right here, we've got an x squared. And then right here in this area, in the upper right-hand corner, we've got positive 4x's. But down here in the lower left section, we've got negative 4x's. And then right here with the ones in the lower right-hand section, we've got minus 16 ones. Okay, well, we can combine some terms here. X squared, that's good. 4x minus 4x. 4x minus 4x. What is 4x minus 4x? 4 minus 4 is 0. 4x minus 4x is 0. So our answer is x squared minus 16. Because the positive 4x minus 4x equals 0. These cancel each other out. They zero out. 4x minus 4x is 0. X minus x 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 is 0. So when we write everything out, we need to make sure that we combine like terms on this page in particular and on the third page, and make sure that we collect like terms correctly and write our final answer when stuff either zeroes out or if different numbers present themselves. So this is not the final answer. We want to collect like terms and make sure that this is the final answer. Ladies and gentlemen, I thank you for your time, and finish up the work.